So today we're going to be looking at dilations of linear functions and polygons. So what are the topics that we're going to be covering today? We're going to be looking at, like I mentioned earlier, dilations of polygons, as well as lines in linear functions, and we're also going to look at negative dilations. All right, so let's say for this first example right here, I want to dilate this square by a scale factor of 2, and my center of dilation is going to be at the origin. So what you want to do is you want to find the slope distance. All right, so what I mean by the slope distance is think about how you find the slope given any 2 points. So if I wanted to find the slope from the origin to point A, I would go up 2, left 1. So that's going to be up 2, left 1. So since I'm going left, that's negative. And now the only thing I have to do is just multiply the numerator and denominator by my scale factor of 2. So this gives me 2 times 2 is 4. And then negative 1 times 2 is going to be negative 2. So I go back to my center of dilation and I go up 1, 2, 3, 4. And then I go left 2 units. So that gives me point A prime. So you want to repeat that process for point B, right? And that'll give you B prime here as well. And then let's say for point C, right? So I want to go from the center of dilation to point C. So I don't have to go up or down vertically to reach point C. So I go up 0 units, but I have to go left 1 unit. So now I just repeat the process. I multiply by a scale factor of 2 for the numerator and denominator. So 0 times 2 is 0. Negative 1 times 2 is negative 2. So I go back to my center of dilation. And again, I don't have to go up any units vertically. And then I go left 2 units to get C prime. And then here, I do the same thing for point D to get D prime. All right, so I'm kind of skipping a few steps, especially the repetitive steps, because I don't want to make this video too long. And then the last thing I want to do is just simply connect my dots. All right, so now I have my image. And if you take a look at AC, compare that to A prime, C prime, you'll notice that those corresponding sides are parallel. Same thing with AB and A prime, B prime. Those corresponding sides are parallel. So that's usually a good indication that you're on the right track. Okay, so now let's take a look at another example. So let's say I want to use a dilation point that's away from the origin. So the same process still occurs, right? So we're going to use the slope distance. So let's say I take this line segment and I'm going to dilate it by a scale factor of 3 with my center of dilation 3, 4. So I repeat the process that I did for my previous example. So I want to find a slope from my center of dilation to point A. So that's going to be 0, negative 1. And I multiply that by the scale factor of 3 for my numerator and denominator. So I get 0 over negative 3. So I go back to my center of dilation, and I go up 0 units, and then left 1, 2, 3 units. So I have A prime. And then for point B, so for point B, I go down 2 units, right 1 unit. Down 2 units. Notice I have negative 2 because I'm essentially writing the slope. And then right 1 unit. And then I multiply by 3 for the numerator and denominator, and I get negative 6 over 3. So from my center of dilation, I go down 1, 2, 3, 4, 5, 6 units, and then right 1, 2, 3 units to get B prime. So the only thing that's left to do is to simply connect my 2 points. Now, again, you'll notice that AB is parallel to A prime, B prime. So that lets me know that I'm on the right track. So now let's take a look at another example that's similar to the last one that we just did. So what if I want to dilate functions, and in this particular case, a linear function? Well, the process is really no different. So if I take a look at this line, I do the same thing as I did before. I pick point A and point B. Right, those are points of convenience. You could use other points as well. And so just to save myself a little bit of time, so these were the points I got from the previous example. Right, they're the exact same points. And what I want to do is, instead of just drawing a line segment, I draw a line itself with the arrows and whatnot. Right, so here's my new line. This is essentially my image. And if I want to write the equation of my image, notice my slope is going to be down 1, right 1. So down 1, right 1. Down 1, right 1. And then my y-intercept is going to be 4. So if you want to simplify this, this is going to be negative x plus 4. So this would be the equation of my image. All right. So if we take a look at this next example right here, your teachers probably haven't spoken to you about negative dilation. So the way they work, they pretty much work the exact same way as you might expect. So here's what we want to do. All right. So if we take a look at our triangle ABC, I want to find my slope distance. So my center of dilation for this particular problem is going to be the origin. And my scale factor is going to be 1/2. So my scale factor is going to be 1/2. So I do the exact same process as I did before. So here, for my center of dilation, I go down 2 units and I go left 4 units to get to point A. So that's going to be -2 over -4. And then if I multiply by 1/2 for my numerator and denominator, and if you're not, good with fractions, you can use your calculator. So I take 2 times -2 times 1/2, that's going to give me -1. And then -4 times 1/2, that's going to give me -2, right? So don't simplify this, right? Because the signs are going to give you the direction of where you're going to go. So you might be tempted to write this as positive 1/2, but don't do it, because you're going to lose the directionality of your problem. So I go back to my center of dilation, and I go down 1 unit, left 2 units. Down 1 unit, left 2 units. And that's going to give me point A prime. Right. So here, if I'm multiplying it by a negative number, what I want to do is I'm going to take point A prime, which is going to be -2, -1. And a factor here, it's going to be -1/2. So this is a typo. It should be -1/2. So if my scale factor is -1/2, so I already dilated my triangle, or at least point A, by a scale factor of 1/2. Now the only thing that's left to do is to multiply by -1. So I need to multiply both the x and the y coordinate by -1. And that's going to give me A double prime, +2, +1. So I multiply both the x and the y coordinate by -1 to get +2, +1. And that'll give me point A double prime. Right. So I'm not going to make this video too long, right? But you can repeat that process for point B and for point C as well to get B double prime and then C double prime. And then let me just connect the points. Okay, sorry, I'm using this on a pretty cheap tablet. Okay, so the last example that I want to look at is here you want to find the center of dilation and you also want to find the scale factor. So let's say you're given two geometric objects and you have the image and you have the pre-image. So the first thing you want to do is look for the center of dilation. And how I'm going to do that is I'm going to look at the corresponding points. So here I have A prime and A. Those points correspond. And I'm just going to draw a line through those points. Right. And then I do the same thing for point C prime and C. And same thing for B prime and B. And you're going to notice that all three lines, they intersect at this point right here. So my center of dilation is going to be positive 6, negative 6. So this is my center of dilation. Right. So the next thing I want to do is find the scale factor. And there's this formula that you can use to find the scale factor. It's essentially the image over the pre-image. So here, so if I want to find the scale factor, and let's say I take a look at point C prime, right? And I could either look at the vertical distance or the horizontal distance to my center of dilation. So I'm just going to pick the vertical distance. Doesn't matter which one you pick. So if I take a look, I just count 1, 2 units. So it's 2 units down to my center of dilation. Right, so that's the vertical distance to my center of dilation. I'm not talking about the slope distance, I'm just talking about the vertical distance. So I could then take a look at point C and notice the vertical distance from point C to my center of dilation is going to be 1 unit. So if I take negative 2 divided by negative 1, I'm going to get positive 2. Alright, so this is going to be my scale factor. And you could do this with point A and point A prime and point B and point B prime. It doesn't really matter which one you do. You only have to pick one set of corresponding points to get your scale factor.